Okay, welcome everyone. Today I'm going to be going over the problems from the AMC 8 from 2013. I'm just going to go through each problem and explain the answers as well as the solutions, and you can leave any questions that you have in the chat and I'll be sure to answer them. So I'll start from just question 1. All right. So the first question says that Danica wants to arrange her model cars in rows with exactly 6 cars in each row. And currently she has 23 cars. And we want to know how many more cars she needs to buy. So basically what this means is that the total number of cars has to be a multiple of 6. And the next multiple of 6 up from 23 is 24. So that would imply that she needs one more car. So the answer is A. Okay, the next question says that fish is 50% off today only, and 1/2 pound costs $3 per package. And we want to know the regular price for a full pound of fish. So today we know that it's $3 for a 1/2 pound package. So that means that on a normal day without this sale, it would cost $6 for this 1/2 pound package. And that means that for a full pound, that would be twice that again. So twice of 6 is 12. So it costs $12 for a full pound on a normal day. The third question asks us for the value of 4 times this quantity, which has all the numbers from 1 through 1,000 with alternating signs. So the first one's subtracted and the second one's added. So what we can do is put these numbers in pairs. So we see that these first two add up to 1. The next two also add up to 1, and so on, because the first number is subtracted and the second number is added, but it's always 1 bigger. And since there are 1,000 numbers in total here, that means there are 500 pairs. Each pair adds up to 1, so everything in the parentheses must add up to 500. And now if we go back, we also see that there's a 4 that we need to multiply by. So 4 times 500 would be 2,000. And you can see there's 500 as an answer choice if we didn't pay attention to this 4. Okay, the next question says that 8 friends ate at a restaurant and agreed to share the bill equally. But Judy forgot her money, so each of the 7 other people paid $2.50 extra to cover her portion of the total bill. We want to know what that total bill was. So we can infer that since they're sharing the bill equally, each person would originally be paying X, which is the total bill, let's say, divided by 8. Now, since Judy isn't paying, everyone else is actually paying the entire bill divided by 7. And we know that if we find the difference, we're going to get $2.50. Now, if we find a common denominator, we'll see that 56 is our best denominator. So this x divided by 7 is the same as 8x divided by 56. And x divided by 8 is the same as 7x over 56. So I'll rewrite this down here. You know that it's 8x over 56 minus 7x over 56 is $2.50. And this is the same as 1x over 56. So we know x over 56 is $2.50. Now to find the total bill, we just have to multiply both sides by 56. So we find 56 times $2.50 and we find that that's equal to 140. So that's our answer. Okay, next question. Hammy is in the 6th grade and weighs 106 pounds, and his 4 sisters are babies and weigh 5, 5, 6, and 8 pounds. And we want to compare the average and the median. So we know that the average is going to be the sum of all 5 of these numbers divided by the number of numbers, which is 5 in this case. So if we do 106 plus 5 plus 5 plus 6 plus 8, we're going to get 130. So 130, and then divide this by 5, we'll get 26 as our average. And now for the median. The median is the number that's in the very middle when we write them out in order. So we can see that they're basically already in order. And we see that 6 is the number in the middle because there are 2 to the left and 2 to the right, or 2 smaller and 2 greater. And so we're going to see that the average is bigger by 20. So that tells us the answer is E. Okay, so those are the answers to the first 5 problems. I'm going to scroll down. Okay. All right, next question. So it's telling us that the number in each box is the product of the 2 numbers above it. And we want to find the number in the top row, the number that's missing at the top row. So we'll start from the bottom where we have 600 and we have 30. So 600 must be the product of 30 and whatever number is in this box. So 600 is 30 times 20, which means that this box is 20. And then using the same logic, we know that 20 is 5 times the number in this box, which would be 4. So the answer is 4. Okay. So, problem 7. Trey and his mom stopped at a railroad crossing to let a train pass. As the train passes, he counts 6 cars in 10 seconds. And we know that the train took 2 minutes and 45 seconds to clear the crossing at a constant speed. And we want to know what the most likely number of cars in the train would be. So this is sort of a rate problem. We know that 6 cars come every 10 seconds on average, based on what he saw. So we want to convert this 2 minutes and 45 seconds to just seconds. So 2 minutes times 60 seconds per minute is 120 seconds. Adding on these 45 extra seconds is 165. So what we have is 165 seconds. And we also know that there are 6 cars, all right, 6 cars, C, for every 10 seconds. And if we do this multiplication, 165 seconds times 6 cars divided by 10 seconds, we'll get 99 cars. And that's definitely closest to 100. Okay, next question. We have a coin that's tossed 3 times, and we want the probability of at least 2 consecutive heads. So we need to know the total number of possibilities, as well as the number of possibilities that satisfy our condition. So we have 3 flips, each of which has 2 possibilities, 2, 2, and 2. So if we multiply these all together, we'll get 8 total possibilities. And now we want the possibilities that actually satisfy our condition. Well, the only way we could have two consecutive heads is if the first two were heads and the last one was tails. First one's tails, the next two are heads, or if all three are heads. So these are the only three possibilities that work. So 3 out of 8 total possibilities, that's 3/8. Okay, next question. The Incredible Hulk can double the distance he jumps with each succeeding jump. And his first jump is 1 meter, and so on. So we want to know which jump he can jump over 1 kilometer. So first we need to know that 1 kilometer is equal to 1,000 meters. And then we'll look at the powers of 2 since his distance is doubling every time. Well, we know that the first jump, he's going 2 to the 0 meters, 1 meter. And we know that on the second jump, he is going 2 to the first meters, 2 meters. On the third jump, he goes 2 to the second power, which is 4 meters, and so on. And our powers of 2 say that the first power of 2 over 1,000 is 2 to the 10th power. 2 to the 10th power is equal to 1,024. And so when is he going to get here? Well, you can see that on each jump, his power of 2 is 1 less than the jump number. So he's going to get to 2 to the 10th on the 11th jump. So that's our answer. Okay, I'm going to use red so I can have more space. So next question, we want the ratio of the least common multiple of these two numbers to the greatest common factor of these two numbers. So the first thing we're going to want to do is find prime factorizations, right? So 180 is equal to 6 times 30, so 2 times 3 times 30, which is 2 times 3 times 5. And we have 594, which is also equal to 600 minus 6. So that would also be 6 times 99, since it's 6 times 100 minus 6 times 1. So we'll start with 2 times 3 again, and then 99, which is 3 times 3 times 11. So for our least common multiple, we're going to have 2 squared, since 180 has 2 squared. We're going to have 3 to the third power, since 594 has 3 powers of 3. Remember, we're taking the larger power of each prime here, since that's the least common multiple. And then we have 5 and 11 from each of the two numbers. Now, when we find the greatest common factor, we're basically doing the opposite. We want to find only the factors that they have in common. We see that they have a 2 in common, a 3 in common, and another 3 in common. And so when we divide this out, 2 squared divided by 2 is 2. 3 to the third divided by 3 is 3. And then 5 and 11 are not canceled out. And if we multiply all of those numbers together, we'll get 330. So that's that question. Okay, problem 11. Ted's grandfather uses his treadmill 3 days this week. He does 2 miles every day. So on Monday, he goes at 5 miles per hour, and then 3 miles per hour on Wednesday, and 4 miles per hour on Friday. If he walked at 4 miles per hour the entire time, he would have spent less time overall. And we want to know how much time he would have saved. So we need to see how much time he spent each day. On Monday, he goes 5 miles per hour. So every hour there's 60 minutes, which means that it takes him 12 minutes to go 1 mile. So that means he's going to spend 24 minutes on that treadmill. And then the next day, he goes 3 miles per 60 minutes, so that's 20 minutes per mile. So if we double that for 2 miles, that's going to be 40 minutes. And finally, 4 miles per hour on Friday. So 4 miles in 60 minutes, that's 15 minutes per mile. So for 2 miles, that's going to be 30 minutes. Okay, now let's look at if he had walked 4 miles per hour steadily. So that means that each day would be like Friday. He would just spend 30 minutes each day for a total of 90 minutes, right? 3 times 30. And if he okay, wait, hold on. So in total for the way he actually ran, that would be equivalent to 94 minutes, right? So adding our 3 numbers up. And so we can see that going 4 miles per hour steady, he would have saved 4 minutes. Okay, that's all of those problems through problem 11. Let's keep going. So problem 12. We have a fair where buying 1 pair of sandals at the regular price of $50 gets us a second pair 40% off and a third pair at half price. So if we buy 3 pairs, we want to know what percentage of the $150 regular price we would save. 150 because 3 times the regular price of 50 is 150, right? So we know that the first pair is going to cost us $50. We can't avoid that. We don't have a sale for the first pair. The second pair, we're going to get 40% off. So 40% off of 50, we're going to spend $30. And finally, the third pair at half price is going to be $25. So all in all, we're spending $105. So if we added all 3 of these up, we get 105. And that means we've saved $45 out of the 150 regular price, right? So this percentage is 30%. So our answer is 30%. Okay. So for the next question, when Clara totals her scores, she inadvertently reversed the units digit and tens digit of one score. And we want to know what the incorrect sum might have differed from the correct sum by. So we want to know like how far that could have thrown off her answer. So if we think about a 2-digit number that she reversed, we can call the original number 10a plus b if the original number were ab. Since a is in the tens place, it's basically 10 times a plus b. And when she reverses it, that's going to be 10 times b plus a, because it's going to be b a. And so if we find the difference between these two, we'll find that the difference is 9a minus 9b. And we want the positive value since we're finding a difference. So if a is bigger, then it would look like this, but if b were bigger, maybe it would look like 9b minus 9a. So we see that no matter what a and b are, it doesn't really matter. It's going to be divisible by 9, since both of these are multiplied by 9. So we want the answer that's a multiple of 9. And 45 is the only multiple of 9 out of these answers choices. Okay, question 14. Abe holds 1 green and 1 red jelly bean in his hand. Bia holds 1 green, 1 yellow, and 2 red jelly beans. If they each pick a random one, we want the probability that the colors match. So we see that if Bia picks her yellow jelly bean, there's no way they can match since Abe doesn't have a yellow jelly bean. But if she picks any other jelly bean, there's a 50-50 chance that Abe will match that jelly bean. So what's the chances that Bia picks a non-yellow jelly bean? Well, that's 3/4. Since she has 3 non-yellow jelly beans, I have 4 total. And we want the probability that Abe can match that jelly bean, whatever it is. So that's going to be 1/2 since he has 2 jelly beans. And that's going to be equal to 3/8. We multiply our numerators across and denominators across. Final answer, 3/8. Okay, question 15. If 3 to the p plus 3 to the 4th equals 90, 2 to the r plus 44 equals 76, and 5 cubed plus 6 to the s equals 1421, we want the product. So we'll look at the first one. 3 to the 4th is 81. So subtracting 81 from both sides, we want 3 to the p is equal to 9, basically. So it's going to tell us that the first number we need is 2, since 3 squared is 9, so p is 2. Next, we consider subtracting 44 from both sides. If we subtract 44 from both sides, we get 32 on the right side. And we know that 2 to the 5th power is 32, so r must be 5. Okay, and finally, we have 5 cubed, which we can subtract from both sides. We'll subtract 125 from both sides. And on this right side, we'll get 1,296 after doing that. And 6 to the 4th power is 1,296. We could have found that by first considering 6 squared, which is 36. Multiplying by 6 again is 216. And then multiplying by 6 again, we get our correct answer. So that's going to mean that S is 4. So multiplying our 3 numbers together, we get 40 as our final answer. Okay. A number of students from Fibonacci Middle School are taking part in a community service project. And we have the ratio of 8th graders to 6th graders is 5 to 3, and the ratio of 8th graders to 7th graders is 8 to 5. And we want to know the smallest number of students that could be in the project. So since we cannot have fractions of a student, we need whole numbers of students, right? That means that the number of 8th graders has to be a multiple of 5, and looking at the second ratio, the number of 8th graders also has to be a multiple of 8. The smallest multiple of 8 and 5 is 40, so we'll see if that works. So if we have 40 8th graders, then we will have 3/5 of that for 6th graders. So that means we're going to have 24 6th graders. And then looking at 7th graders, we're going to have 5/8 that number, which is 25. So this all works. We have a whole number of students in each grade, which is good. And then when we add these 3 numbers up, we get 89. Okay. So those are the answers up through question 16. All right, I'll scroll down now. let's see. The sum of 6 consecutive positive integers is 2013. We want to find the largest integer. So if we consider 6 consecutive integers that add to 2013, they're all going to be pretty close to 2013 divided by 6, right? Because they're all pretty close to equal. But what we also can see is that we can pair the numbers up like this. Okay, yeah. So pairing them from the outside and then moving inwards. And since we get one bigger this way and one smaller this way, each pair of numbers adds up to the same number. So since we have 3 pairs, each pair will add up to 2013 divided by 3. And 2013 divided by 3, 2013 divided by 3 is 671. So each pair of numbers adds up to this. Well, if we divide this by 2 so that we can get down to each individual number, 671 divided by 2 is 335.5. So since these two numbers both have to be integers, we can subtract 0.5 for the first one. So 335, and add 0.5 for the second number. That's 336. We want to know what the largest integer is. So 337, and then finally 338. So that's our answer for this question. All right. Moving on to the next one. We have a box that we are building out of 1-foot cubicle blocks. The dimensions are given, and we want to know how many blocks the fort contains. I'll scroll down now so you can see the answer choices. So remember, we're counting the number of blocks. So first, we'll consider just the bottom. Bottom is 12 by 10, and we were told that the bottom and the walls were all 1 thick. So 12 times 10 times 1 is 120 blocks. And now we'll consider the walls. So since we already considered the bottom, the rest of the box is now 4 high, right? And what we want to know is basically how many blocks are in one perimeter, one ring. Well, it would be 10 for this side, 12 for this side, 10 for this side, and then 12 again, right? So if we add those up, that's 22 times 2, 44 blocks around the perimeter. But what we've done is actually counted the corner blocks twice. Once for the length and once for the width. So since we counted 4 blocks twice, we want to subtract 4 from 44, and we get 40. So each perimeter is 40. So 40 blocks times 4 high is an additional 160 blocks. And so if we add those two numbers together, we get 280. So that's our answer for that question. Okay, next we have Bridget, Cassie, and Hannah, who are discussing the results of their last math test. Hannah shows her test to the other 2 people, but the other 2 people don't show their test to anyone. Cassie says, I didn't get the lowest score, and Bridget says, I didn't get the highest score. And we want to know what the ranking is. Well, if Cassie knows that she didn't get the lowest score, that means that her score must have been higher than Hannah's, since that's the only way she would know she didn't get the lowest score. So Cassie did better than Hannah. and Bridget says she didn't get the highest score. The only way she would know she didn't get the highest score is if Hannah did better than Bridget. So what we're looking for is the answer Cassie did better than Hannah, did better than Bridget. And since it's asking for highest to lowest, we're looking for Cassie, Hannah, Bridget, which is D. All right, next question is asking for a semicircle, so I'll use a full circle, but why don't I cut it in half? We also have a rectangle that's inscribed inside the semicircle. And we're saying this rectangle is 1 by 2. It's not to scale, but it's close enough. We want to know what the area of the semicircle is. So we'll take the center of the circle and we'll draw a radius. So we know that this side is 1, and we know that this side is also 1 because we've cut the rectangle in half, basically. And using the Pythagorean theorem, the hypotenuse squared is equal to 1 squared plus 1 squared, which is 2. So the hypotenuse squared is 2. That means our hypotenuse is the square root of 2. Note that we also could have used this radius as well. We would have gotten the same thing. So now, to find the area of the semicircle, we'll first use our formula for the area of a circle, which is pi times the radius squared, which would be, in this case, be equal to pi times 2, since the square root of 2 squared would be 2. So far we have 2 times pi, but we only want the area of a semicircle, so we don't want this section, right? Even that's included in 2 pi. So we're dividing by 2. And that leaves us with just pi. So that's C. Okay, on to the last 5 questions. Okay, so Samantha lives 2 blocks west and 1 block south from the southwest corner of the city park. So I'll draw the park here. You can see she lives 2 blocks west, 1 block south. When the school is 2 blocks east and 2 blocks north from the northeast corner. And we're told that on school days, she bikes on streets to the southwest corner, takes a diagonal path through the park, and then bikes on streets to school. And we want to know the number of routes she can take if her route is always as short as possible. And when we're told that she bikes on streets, that implies that we are not taking diagonal paths because we can't go through buildings, since these are probably blocks that have buildings on them, right? So let's think about how many routes she can take. What we want to do is find how many routes she can take from her home to this corner, and then from northeast corner to school. And we can take those 2 numbers and multiply, since each of those are independent of each other, right? Neither route affects the other. So the first half is independent from the second half. So she can obviously take 1 up and then 2 across, or she could take 1 across, 1 up, and then 1 across. She could also take 2 across and then 1 up. So that gives her 3 possibilities for the first part of our trip. For the second part of our trip, it's a little more complicated, but we can still list them out. She can go across, across, up, up, across, up, across, up, go across, up, up, across. So those are three possibilities where she starts by going to the right. Now there are more possibilities if she goes up first. So she could do two ups, and then two rights, and up, right, and up, right. Or she could go up, right, right, up. So those are the six possibilities that she can do for the second part of her trip. So there are six possibilities there. And because these two are independent, like I said, we can do 3 times 6 for our final answer, which is 18. Okay, next question. We have toothpicks that are used to make a grid, 60 toothpicks long and 32 toothpicks wide. We want to know how many toothpicks are used in total. So looking at our grid, we're basically just outlining these squares. And let's think about how many rows of toothpicks we're using. We're told that it's 32 toothpicks wide, so there's 32 toothpicks down. But that means that we have 33 rows, because if we only had one wide, so if this were the only toothpick, one wide, we'd still have two across, 2 rows. But if we had 2 wide, then we would have 3 across, 3 rows, right? So the number of rows will always be one more than it is wide. And using the same logic, we can show that the number of columns is one more than it is long. So if it's one long, we have 2 columns, and so on. So we're going to have 33 rows, and each row, we're told, has 60 toothpicks. So that's going to be all of the toothpicks across that are horizontal. For the toothpicks that are vertical, we're going to have 61 columns, since it's 60 long, and then each column will have 32 toothpicks. So if we multiply these two, we will get 1952, and we'll get 1980. And if we add these two numbers up, we will get 3,932. Okay, on to the final questions. We have 2 geometry problems here. We're given a triangle, a right triangle, and they all have semicircles on them. So immediately we're told it's a right triangle. We draw a right angle. We are also told that the diameters, well, the sides of the triangle are diameters for semicircles. We know that the area of the semicircle on AB is 8 pi. So this is 8 pi. We're told that the arc on semicircle AC, so tracing this, has length 8.5 pi. And we want to find the radius on BC. So we'll start by looking at this one with the arc. In a full circle, the arc would be twice 8.5 pi, which would be 17 pi. And in a full circle, the circumference, or the perimeter, is always pi times the diameter. So 17 pi is pi times the diameter. The diameter is therefore 17. Onto AB. So the semicircle has area 8 pi. So if you imagine a full circle, it would have area 16 pi. Now we know the area for a circle is pi times the radius squared. So since the radius squared is 16, the radius is 4. So the diameter is 8, since the diameter is twice the radius. So that means that AB is equal to 8. But how do we find BC? We don't know anything about this semicircle. Well, we know this is a right triangle, and we're given 2 of the sides. So we can use Pythagorean theorem to find the last side. So we know 17 squared equals 8 squared plus 15 squared. Or not 15 squared, sorry, BC squared. But we can find out that BC squared is 225 by doing 289. 17 squared is 289, and then 8 squared is 64. So if we subtract, we could find that BC squared is 225. And then we could find that BC is 15. So just working from subtraction and then taking the square root. So we know the diameter is 15, but we don't see 15 as an answer choice. Well, going back to the question, we want the radius. And the radius is going to be half of 15. So that's going to be 7.5. Okay. Moving on to question 24. We see we have 3 squares that are equal in area, and then C and D are the midpoints of IH and HE. So basically what you see is that this square is resting right in between the 2 squares below. I want the ratio of this pentagon to the entire thing. So we'll look first at the entire thing. If we assume that the side length is 1, then each square has an area of 1, and that means our total area is 3. So all we need to do is find the area of our pentagon and then divide by 3. So it's not immediately obvious how to find the area since we can't really figure out this length that easily. Right? This length is not very clear. But if we add on a rectangle here, we can see a triangle form. And this triangle can be found quite easily. So if we look at A to this point, which I will call X, BX is 1/2, since we were told that C was a midpoint. So this base is 1 plus 1/2, which is 1.5. Right? AB is 1, and BX is 1/2. So this is 1.5. Okay. Now for the height. The height of this triangle is 2, since it's basically just how high these boxes are, right? IJ is 1 and XI is 1. So this is 2. So the area of this triangle is the base times the height divided by 2, or 1.5 times 2 divided by 2, which is 1.5. However, we still need to go back and subtract this rectangle since it's not actually part of the pentagon. Luckily, this is not very hard because BX is 0.5 and XI is 1.5. So 0.5 times 1 is 0.5, so the area of this rectangle is 0.5. We don't divide by 2 because it's not a triangle. So we subtract 0.5, since this rectangle was not part of this pentagon, we get 1. So our pentagon has area 1. So the final ratio is 1 to 3, or 1/3. That's how you do that question. Alright, on to the last one, the finale. So we have a ball with diameter 4, and it's going to roll along this track. The track is 3 semicircular arcs, and we're given their radii, so 100, 60, and 80. We're told that the ball always remains in contact with the track and does not slip. We want to know what the distance the center of the ball travels is from A to B. And B isn't labeled, but it's right here. That's B. So the problem is that we cannot just calculate the length of these arcs because the center of the ball is not on the arcs. Since the diameter is 4, the center will always be 2 inches away from the arcs. But the diameter of the ball is actually going to trace out a smaller semicircle, basically. So it's always going to be 2 inches away, so we're just drawing a smaller semicircle here. But when it gets to R2, it's actually going to draw a bigger semicircle. And then at R3, it draws a smaller semicircle again until it gets to B. The center will not actually hit B, but the outside will hit B, just like how the center is not on A at the beginning. So what we need to now find is the radii of our 3 new semicircles, right? So since the diameter of the ball is 4, we're going to be 2 inches away from the ends. So since the radii of the first semicircle is 100, our new radius is going to be 98 inches, since we cut off 2 inches. Now for the second semicircle, we started with a radius of 60, but we're actually adding 2 inches since we go on the outside here. So we have 62. And for the final semicircle, we're back to being a little bit smaller. So it's going to be 2 inches smaller, so 80 minus 2. It's going to be 78 inches in radius. Now we need to find the distance that the center of the ball travels. So we need to find these circumferences, basically. But it's not circumference, right? It's only half of it. So if we find the diameters, we have 196, 124, and 156. So if we find the circumference of our imaginary full circle, right, we can imagine having a full circle. The circumference would be 196 pi, since we would multiply the diameter by pi. But since we only have a semicircle, it's only going to be half of it. So that's basically going to be 98 pi. So that means we can basically just take the radius and multiply by pi to find the length of half of the circle. So then we can do the same thing for the other 3 semicircles, or the other 2. And our final answer will be 98 pi plus 62 pi plus 78 pi. And that's 238 pi. That's our answer for the last question. Okay, so those were all of the answers and solutions for the AMC 8 from 2013.